All right, here's our first section in our first video in section 4.7. We're going to now talk about polynomials with multiple different variables in them. I think so far all we've done is polynomials that have a single variable. They all have x's or they all have y's. Now we're going to talk about polynomials that have x's and y's and z's, maybe multiple variables, right? And so we're going to simplify multiple variables here. The first thing we're going to talk about is evaluating. So for example, if I give you this polynomial, 4 plus 3x plus xy squared plus 8x cubed y cubed, and I want you to evaluate it when x equals -2 and y equals 5. Now we've evaluated polynomials before for just one variable. All we're doing now is evaluating with two different variables. Wherever we see an x, we're going to plug in a -2, and wherever we see a y, we're going to plug in a 5. So I'm going to take my polynomial, I'm going to rewrite it, and I'm going to substitute in a -2 wherever I see an x, and a 5 wherever I see a y. Being very careful with your signs, parentheses, and your exponents. From here, we have to make sure that we follow the correct order of operations. Remember, please excuse my dear Aunt Sally or PEMDAS. We have to make sure that we do our exponents first, then we have to multiply, and then we have to add or subtract. So here we go. I took the 3 times -2. That gave me a -6. I took the 5 and I squared it. That gave me 25. I took the -2 and I cubed it. That's -2 times -2 times -2. That gave me a -8. And then I took the 5 and I cubed it. So I did a couple of different things at the same time. I did my exponents, and then if I had a multiplication that was separate in a separate term, I could do that as well. I still have some more multiplication. So it looks like here I still need to multiply the -2 times the 25. And then I still need to multiply these three numbers together, the 8, the -8, and the 125. So I ended up with a 4 plus a -6, or I can say -6, minus 50 minus 8,000. Your final answer should end up being -8,052. We're simply just plugging in for each variable and simplifying, just making sure that we stay organized and we follow the correct order of operations. Let's do another problem that's a little more application-based. Example number 2 says the surface area of a right circular cylinder is given by the polynomial 2 pi rh plus 2 pi r squared. If you think about surface area, for example, this soda can is a circular cylinder. We have the top and the bottom, that's two circles, right? And if we want the area of those circles, we want a pi r squared. Since there is a top and a bottom, two of them, that's how I can multiply it by 2. And then we want around the outside of this soda can. To find the area of the outside, I'm going to do 2 pi rh, where h is the height and r is the radius of the base. A 12-ounce soda can has a height of 4.7 inches and a radius of 1.2 inches. This question is asking us to approximate the surface area to the nearest tenth of a square inch. So if we know the surface area is this formula up here, we should be able to take that multiple variable polynomial, right? I have r's and h's in there, and it's just a polynomial separated by a plus or minus sign. I have two different terms here. I should be able to plug in 4.7 anywhere I see an h for the height, and a 1.2 for the radius anywhere I see an r. So that's what I'm going to do now. So I plugged in a 1.2 for my radius, a 4.7 for my height. Remember, they're both in inches, so if I multiply them together eventually, I have inch times inch, which is square inches, right? I'm going to plug in my 1.2 for my radius here. Remember, that's still, again, inches, but when I square it, I end up getting square inches. When we talk about area, our final answer should be in units squared, or inches squared in this particular case. From here, I'm just going to follow my correct order of operations. I'm going to multiply. I'm going to square and then multiply. You notice that I have a whole bunch of decimals, numbers in my decimal, that I want to either keep in my calculator or write out as many decimals as possible so that my final answer is as accurate as possible. I don't want to round yet because I don't want to risk rounding my answer too much. So I'm going to use my calculator and write out as many decimals as possible. The question asks us to approximate to the nearest tenth of a square inch. So that's one decimal place. So for on this one, If we were rounding to one decimal place, I would say the surface area of this soda can is approximately 44.5 square inches, using our information and just plugging in and evaluating.